My name is Igor, and I'm a part of their Cube team where we're building the headless BI. And also, I'm really happy to see my colleagues Adnan and Ray joining this call. Yeah, and I think we had a really great start with the conversations and chat, and I encourage everyone just to use that, and also the Q&A tab to be asking questions. I think that both me and Adnan and Ray will be happy to take your questions, if any, asynchronously, and also we'll have a Q&A session in the very end.
We will. And I'm Shrisham. I'm from the preset side of things. So when we get into the visualization and Superset, that's what I'll be talking about. But I'm excited to join the Cube folks here. They're wonderful partners, wonderful product. So yeah.
Cool. Okay, with that, let's jump into just maybe a couple of slides or not a lot of them. So the structure for this webinar would be that we'll just shortly, very concisely cover, just a couple of basic things about Looker. Then we'll tell you about the tools that we're building, that we represented as called Cube, and Superset, and then we'll tell all about how they work together and why would any data team enjoy using them together. And then we'll have the demo part where we'll show you very hands-on how Cube can be set up, how Superset can be set up to work with Cube, and how beautiful visualizations can be created, so you can really get some sense, get the insights from the data you're working with. So and obviously after all this, I guess we should still have like 15 or maybe 10 minutes of time, which will spend taking the question that are not answered asynchronously in the chat yet. So yeah, without further ado, let's get started. And yeah, for those of you who have come to this webinar without reading the blog post that was posted both on Preset blog and also Cube's blog, feel free to check it. It was posted just a few days ago. So yeah, that's kind of the concise written version what we're going to cover at this webinar. But without the live demos, so attending this webinar is also a good one. So let's talk about Look. I think that, well, maybe not everyone on this call, but I guess fair share of us. But at least that's true for myself. We should be grateful for a couple of things about Looker. First, I think that the acquisition of Looker done by Google when Looker joined the GCP family of products, that was a really big thing in the data space because it showed the pulse for many other emerging data products and the explosion that we have right now in the modern data stack. I think this is in part due to this success, right? And also, I think Looker was one of their products, if not the first one, who popularized the use of business intelligence platforms hosted in the cloud with cloud data warehouses, right? And yeah, here I can jump back to their BigQuery support part that was mentioned in the chat, right? The BigQuery support that Looker got after the acquisition, that's a good part as well. And also, there is a thing which is very relevant to what we'll be covering later. This is their ML language or data model definition language that Looker uses. I think again that was a good example of how data models can be declared, can be defined declaratively, right? And there are a lot of tools, Cube included, which got inspired by this approach and evolved and built on this approach. However, there are parts about Looker which are not so good. I think that one of them is that, well, this is something that may be prohibitively costly to use, right? And not every data team from mid-sized companies, from small companies, is able even to think of using Looker, right? So because of this, and also there are a lot of features that are basically locking you in, right? So if you take LookML models, right? If you have a lot of LookML, you'll probably have very hard time migrating to some other headless BI tool, a metrics layer, or to other BI solution in general, because, well, you'll have to somehow to remodel your data and think about, how many changes would be needed kind of downstream to adapt to the removal of Looker. Probably you'll just need to rebuild everything from scratch, right? And I think that this is debatable, but another feature of Looker that it's different feature. They are kind of very coupled together, right? So basically, if you like their data modeling layer, but you dislike, say dashboarding functionality, well, you're trapped, right? You don't have very much options how to deal with this, and if you want to make sure that the data is accessed by the other teams using other tools, data notebooks, or maybe custom built customer facing front-end apps, well, you'll have to use what Looker provides, and if that's not that you're content with, then well, I don't have that much of options. Yeah, and well, we've seen the news earlier this year. These were not very pretty news, but yeah, that probably only affects current Looker users. So yeah, let's proceed. Okay.
There was one thing I just wanted to chime in on. Like, if you even just take a look at like the LookML documentation, for example, you can see just how like sort of convoluted it is to like keep track of all of these data models and everything. And if you're from an engineering background, you do know what the value is in using something like SQL, which is known as like the lingua franca of data analysis. So open source tools help in that way, where you can port all your code because it's reusable. It's common languages. It's nothing too in the weeds that you just have to go and like kind of unbundle the way Igor mentioned. Just wanted to throw that in there.
Yeah, right. So some reasons that lead us to seeking for an alternative for Looker, that might be their urge or just the intention to lower the entry barrier for the data teams, right? And also use the tools in the presence of many tools in the modern data stack, which embrace the separation of concerns and just, have less vendor lock-in. And I can't say that there are tools that kind of doesn't lock you in entirely, but having less of lock-in, that's better for, just in the long run, right? And also the tools in the data space, they're complex, and you'll definitely be face issues with them. You'll be seeking for help. And in that case, great documentation helps, and other resources which are provided, they also help. But nothing replaces growing and big vibrant communities that are very common for open source products, right? So I understand this is not kind of an exhaustive list of reasons to seek for an alternative, but there are at least some. Okay, and with that, let's talk about Cube and Superset and what these tools can do, how they can work together to provide a viable, and I would say very much viable alternative to Looker. So let's talk about Cube. I come from the Cube team, right? And our mission at the Cube team is to make data consistent and accessible. And to achieve that, we are building the tooling for data practitioners, and our product is called Cube, right? And this is a headless BI platform. So you can think of this as a BI solution, which is deliberately visualization agnostic, right? So it doesn't care about the way the data would be visualized or represented in the BI tool, in the data notebook, on the front-end app with embedded analytics, but it makes sure that the data would be consumed, fetched, read from their data store, that the data would be organized into consistent metrics definitions in the data model, and then that data would be delivered to every data consuming application, whatever that application is, and that obviously includes BI tools like Superset. So that's what Cube does. And visually, you can think about Cube as a tool which solves this problem of kind of too many dependencies that data teams have to deal with between the data sources and data consumers. So this is what probably many, well, not probably, that's what definitely many data teams have right now. There's a lot of data sources, or maybe just just a single data warehouse, data lake, and then many tools alongside, BI tool for internal consumption that need to work with the data in those data sources, and then there are kind of siloed metrics definitions in between. The cube solved this just because it serves as a single source of truth for the metrics definitions and provides kind of consistent data by reading it from the data sources and exposing them to data consumers via the APIs. So Cube provides kind of centralized way to access the data, define the metrics, make sure the data is secured with the access control layer, make sure the data is accessible in milliseconds rather than seconds and minutes, which is not so uncommon in the not very modern part of the data space, and then delivering those metrics to the data consumers. Yeah, so this is what you can expect in terms of consistency because of their position that Cube has in their data stack. And let's do a deep dive into data modeling. So as I said, the data modeling part of Cube, it is inspired by Looker, and the data model that the Cube uses, which is declarative, it's really similar to LookML. However, well, it definitely looks less proprietary because in Cube's case, it's just syntactically correct JavaScript. Looks like a JSON object. And what we are currently working on, and we'll be launching this later this year, there are other alternative dialects for the data model that they're going to be a YAML dialect, the Python dialect. So just stay tuned for the updates. And having this declarative data model inside Cube just saves you the effort because you don't have to define metrics in different tools, and also ensures that since this is the only place where metric definitions are placed, there is no room for inconsistency. So yeah, we'll have a live demo part, but just you can take a look at their data model, the screenshot. Okay, and in terms of accessibility, what Cube has is a set of APIs, right? And if you're thinking of replacing Looker and using Cube with a BI tool like Superset, you're surely interested in the SQL API. This is one of the APIs that Cube exposes, and the great thing about the API is that it implements their Postgres Fire protocol. Basically, it for any data consumer, for any BI tool, for any data notebook, it looks and behaves as a Postgres database, right? So if your BI tool, if your any data tool works with Postgres, well, it's safe to assume it works with Cube, right? So you're able to, well, maybe write your queries by hand, like a query that you can see on the slide. You can let your BI tool like Superset generate those queries for you, and Cube SQL API will just work with those queries and serve the data that you expect it to serve. Right. So this is the moment we jump into their Superset part, and Srisham, feel free to take over the screen share. Oh, Srisham, you're on mute, so probably it would be great to come back a few seconds.
I love it when that happens. So let's quickly talk about what a superset is. And it's in the theme of like open source. So Superset is an open source BI platform that works with nearly any SQL speaking data engine. And what it does is it offers a large diversity of charts to create dashboards and visualize your data, essentially. And within Superset, there are typically two main workflows, one being Explore. And what Explore does is it provides you with a no-code chart builder. And in the chart configuration itself, what Superset will do is it generates the queries on behalf of the user via SQL Alchemy. And typically the people who are going to be more comfortable with this workflow are really your data explorers and consumers, those looking to gain insights into your data without having to be too technical. So really writing SQL, reading SQL, that's not interesting to them. They care much more about the data being presented in a consumable fashion. The other main workflow is supported by SQL Lab, which provides you with a full SQL IDE. And in this case, the Superset user actually generates their own SQL queries. And Superset essentially leaves it untouched. It queries the data exactly where it lives. And this will typically be more used by like your analytics experience builders, people like data engineers, data scientists, or more technical data explorers like analytics engineers, for example. And in the demo, we're gonna be seeing the visualization in a hosted Superset within Preset. So just to quickly talk a little bit about what Preset is. Preset Cloud is a multi-workspace cloud-hosted Apache Superset, has all the functionality of Superset with additional layering onto SOC 2 compliance. We have our end user documentation provided, row-based access control and single sign-on, as well as support for all of this. And even Superset users can submit tickets that our support team handles and will talk you through. You don't have to just be a Preset customer to get access to this. And we also have an embedded SDK that is currently in beta, but being tested. Preset Managed Private Cloud is simply Preset's platform, but for your AWS cloud. So this, I guess Igor touched on already, but so how Cube and Superset address some of the issues that we saw with like vendor lock-in and all of that. There's a low entry barrier where if you're an engineer and you don't feel like paying for your new products, you're free to go and use, open source Cube, open source Superset, even access the freemium tiers of the managed products themselves. Separates your concerns from vendor lock-in. Everything you see within Superset is almost pure SQL. You can see the queries that are actually generated by the charts, and you can take all of this with you. Superset dashboards can be exported and managed as code. Check out our resources if you want to learn a little bit more about that. And it just works better with tools that are built, in this open source fashion where they're not looking to lock you in and keep you there. And hopefully, we're good representatives of the community. So the great community and support. I think I can pass this back to Igor. If you had anything here, go ahead.
Sure. Okay, yeah. Resharing my screen. Yeah, here we go. Okay, so and here we come back to the not so good parts of looking at the reasons to look for alternative solutions. And yeah, as you can see, well, everything is just repeated on this slide, right? So we can do a quick recap, and yeah, let's break this into smaller bites, and let's see how Cube and Superset really address the outlined issues. So first of all, post products, they are open source. Cube was created in 2019, and it was created as a result of pivoting another data startup called StatsBot. And Superset, as far as I know, and well, I think I know it right. It was created by a great person, Maxime Boucheman, who worked at Airbnb, right? And Maxime is author of both Superset and Airflow, two great products in the data space, right? So a few years after being open source at Airbnb, Superset was moved under their Apache Foundation umbrella, and now it's a very vibrant, very popular open source project. So you can probably tell that by the number of GitHub stars that Cube and Superset have. So being open source, these tools, well, ensure that you have less vendor lock-in, that you can get the changes that you want in the products from the community, and well, that happens all the time. So feel free to check the GitHub, the GitHub repositories, and see how active those communities are, and how and how features are added to both products. Yeah, and Trisham already covered their preset cloud part. This is a great way to get started with Superset. When I'm thinking about launching in Superset workspace in a Docker, my machine, or somewhere in the cloud, or using preset cloud, I'm always defaulting to the latter option. And well, just in the same fashion, there is a managed platform for Cube, which is called Cube Cloud. No surprise here. So again, when I'm thinking about using Cube, I have to choose between launching it in Docker or self-hosting it, somewhere in the cloud, or just using Cube Cloud. And since Cube Cloud is free to start with, and it provides some great tooling that we'll be demoing later today, this is also a very good option to get started with Cube. So highly recommended. Okay, and another thing that is very good about this particular bundle of products, this is a separation of concerns that Cube and Superset provide. Well, when you're using Looker or many other kind of traditional full-fledged BI tools, you have to deal with whatever that tool provides, and the room for customization, the room for interoperability with other tools is slim. And in case for Cube and Superset, there is a clear delineation between the concerns that these tools address, right? Cube takes care of their data access and data modeling. You can also use Cube to ensure the data is secure, to tune the access control and set up the caching for your data. And then Cube delivers the data, to Superset, and its duty is done. And Superset takes care about their charting and presenting their data on the dashboards, organizing them into workspaces and team collaboration with all that. And I'm sure that at least some of you should be aware of the recent launch of their preset embedding SDK. And obviously with that, Superset can also serve not only as your BI tool of choice with dashboards, but also as a tool that can deliver the embedded analytics experience into your custom-built front-end apps. So these are parts which these tools do great, and they're happy to have those responsibilities. Okay, so, and yeah, go ahead.
That was one of the sides. Yeah, I just wanted to chime in more with like Superset's philosophy and Preset's philosophy to this sort of stuff. So like we mentioned, Superset works best by connecting to a data source and querying the data where it lives. We have an intentionally thin semantic layer because the purpose of Superset is not to perform data transformations or manage a semantic, an intentionally thin semantic layer, because we do not want Superset to be used as a data transformation tool. The ideal way to use Superset is with a data set centric approach to modeling. And just to quickly summarize what that is a data set centric approach implies that well-normalized data sets are being used to derive richer data sets with extra semantics, which is really what Cube excels at. So this is what makes them much more valuable for analysis and visualization, because by creating these sort of pre-aggregate metrics, these derived data sets that incorporate all of these things and calculations earlier in the ETL ELT process, before surfacing visualization, a lot of the issues around things like change management, maintenance, logic reuse within dashboards are significantly reduced for a better experience, which is what everyone really wants, especially when you're using a dashboarding tool. Nothing sucks worse than, those spinning wheels waiting for what you would think is a millisecond query to take minutes. And you can read more about our thoughts on that and what the modern sort of data ecosystem looks like at both of our blog websites, which we have linked in the chat below. That was really the only thing I wanted to mention here. So feel free to continue.
Cool. Let's proceed then. Okay. So yeah, a little bit more on their having less vendor lock-in. So in the reason you decide to adopt their Cube with Superset stack, and then for some reason you wanna drop one tool or the other, well, you always have options, right? Because these are two separate tools, and you might want to introduce something else into your stack. So So yeah, one of the way you can drop Cube is to take their queries that Superset runs against Cube, and then the queries that's more interesting that Cubes runs against your data source, and just convert those queries into the virtual data sets that Risham just covered. And that would be your way to go forward. Your Superset dashboards will be intact. This is what you can do if you have a couple of separate tools in your pipeline. And well, if you want to use not only a BI tool, but maybe a data notebook alongside Superset or something else like machine learning pipeline, I don't know, then you can just leverage the other APIs that Cube provides, and you'll be good with this. So this is what you can do if you don't want it to be locked in with these two vendors in particular, but you want to have more, right? And this is.
Oh, I was saying that's exactly what the benefit is. It's because if you use supersets like thin semantic layer, you realize you're doing some complicated transformations. You can always just take this directly and move it right into Cube with basically no loss of service or downtime.
Yeah, exactly.
Also, Igor, can you just stop sharing and resharing? We have a note that some of the attendees don't see the screen.
Sure. So
yeah,
let me
see if that helps.
Share the screen again.
Gotcha.
Can anyone?
Yeah, let's check now.
Anyone see the screen? Okay. Right. So this is this is one of the possible architectures that you can use when Cube and Superset are tied together. So right, the SQL API of Cube will deliver the data to Superset, and then you can use Superset or maybe even employ Preset Embedded SDK to do embedded analytics. Okay, so, and the last but definitely not the least part, and Ray, head of community at Cube, who's with us in this call, can certainly prove that both tools have amazing communities of data practitioners, data engineers, data analysts, and all and application developers, right? And I certainly encourage, if every one of you, if that's not the case already, to join the Slack communities and see this for yourself. And I have really great time, reading about the use cases and that on those Slack channels, and also getting the insights directly from their Superset and Cube users. So this is great to get help, and also a great source of inspiration for building data apps. Okay, so these were the ways that Cube and Superset solved the issues that we were outlining in the very beginning, and that might be not very graphic, and that might be not very convincing. And to make it more graphic and more convincing, let's jump into the demo part. And yeah, I'll be first to demo things, and let's start with the data modeling part. Yeah, so I'm done with the slides, and yeah, so and right now I'll be switching to the Cube Cloud instance. Again, Cube is open source, and you can run Cube in Docker on your local machine. You can self-host it in your private cloud. But what you can also do is get started with Cube Cloud, and you'll get every feature that Cube has, plus some very convenient developer tools on top of that. So right now we are looking at a Cube Cloud instance, and there are a lot of things going on in here, but we're going to focus on data modeling. So here under the schema tab, there's a part with the code, right? So the file is called workspace activation, and you can see that there is some logical entity called workspace activation, and you can see that Cube, I'll be referring to this as Cube, is defined over just a raw table. Like it's just select star from table that has some details about some workspace. I can actually switch to data grouping here and just quickly show you what kind of data is in there. So this is a data about about some bespoke SAS product, and there are a lot of kind of rows with a reporting day and the workspace IDs, different customers in that tool. And for each day, we know whether that workspace was active or inactive. Obviously, the data like this have probably been generated with a data transformation tool, right? So we probably have DBT in our stack, and this is a tool this is a data that we also have. So this data model defines some measures and dimensions over this data set. So basically, measures are the quantitative characteristics, quantitative features of our data, and dimensions are qualitative. So as you can see here under dimensions, we have the workspace ID, we have the reporting day, which is a time dimension, and we have a flag whether this a particular workspace was active or not. And under measures here, we have, well, measures, their count measure that allows us to know how many data points we have. And here are the interesting ones, right? So we have this number of workspaces defined as a distinct count of workspace IDs, and which is even more interesting, the number of active workspaces defined as a distinct count of the workspace IDs for which there is active workspace dimension, which is referenced here, is true. And as you can guess, the definition of this is active workspace dimension would be included in this filter definition, right? So if this were defined as something else, is more complex, not just a column, but something more complex, that would be accounted for in the definition of the number of active workspaces. And as you can see here, you can not only refer to your dimension definitions, but to measure definitions as well. So the activation rate is defined, as the ratio of active workspaces and all workspaces, and we have some math in here, so we have nicely formatted percents, right? And well, this is a data model. You can have many more cubes that logically group your measure and dimensions. You can have other items within cubes, like some items are called pre-aggregation. This is a declarative caching definition. You can also have segments, which are predefined filters, and you have pretty much everything that you have in your LookML files. If you're using Looker, yeah, probably just the syntax is slightly different. So what we can do with a data model like this, so let's jump into another tab called Playground. And this is a place where you can do some initial data exploration just to make sure that the data model is right. Yeah, and we can start with something simple. So basically what you do here is you select measures and dimensions and check the data. So let me select their count measure, and I request just that the count and visualizes a number. So Cube is querying the data from Postgres, and as you can see, we have slightly more than 20 million rows of data in this very slim Postgres instance somewhere in GCP. And well, we can do something more interesting, like we can break this down by, say, months, right? And we can run this query as well. And well, since we have 20 million rows and since we have to do distinct counts, well, it takes some time. And yeah, I forgot to change the visualization type, but indeed it works. So the last thing that I'm going to show here is something that's hidden on the SQL tab. So if you switch to this SQL tab, you'll see the SQL that is generated by Cube, and that SQL is run against the Postgres instance. So Cube takes your query, right, with all the measures and dimensions, and then it takes your data model and uses them to generate the SQL for the underlying data source, Postgres in this case, but it can be BigQuery, Snowflake. There was questions about Trina and Presto, that can be them as well. It can even be KSQL DB over Kafka with your streaming data, but that's a completely completely different topic. Okay, so yeah, you can be tinkering with your measures and dimensions in here, and Cube will be generating the appropriate SQL for that purpose. So probably this is the most complex one that we can get with this data model. Here it is. Okay, the last thing that I'm going to show before we jump into the preset part, I'll just point out that here in the Overview tab, there are the credentials for the APIs, and you can see here the SQL API that you can use to connect Cube to your BI tool of choice, and there are plenty of them available in here. And basically, as I said, anything that works with Postgres as a data source will work with Cube, and Superset works with Cube great as well. So I'm stop sharing my screen. Srisham, feel free to jump in.
And we'll keep this part of it short because, as you can see, the majority of what's going on is happening with Cube itself. So the only real things I wanted to highlight, so Igor actually just showed us already what it looks like to connect it. So it's pretty simple, and I'm going to go to the Cube dev. Where is it? Yeah, there it is. And just show like how that connection actually works within preset. And in this case, we're seeing it in Preset Cloud, but again, the functionality is the same. So if you're a Superset user, this should be familiar to you, but we can actually see that the database is already loaded here. And if I just hit this edit tab, you can see it's simply taking the host URL, port, and everything, and that's what's creating the connection. Now, what I'm going to show is just a quick chart creation first with the data set. So if I hit plus data set, we saw that the active workspaces data set is already there. Give it a minute to load, grab the schema, and the table itself should pop up. And then I'm going to also show you the example dashboard that Igor actually made, where I add this chart that we're going to look at really quick. So we can just hit add dataset and create chart. And we're going to do all of this through the no code dataset workspace activation exists. Okay, that makes sense because it's right here. So instead, what I'll do is I'll create the chart directly. But you can see it helps you, it protects you from yourself. It knew that this was here. I didn't need to like clutter up my workspace. So one of the charts that I wanted to create, so I'll just go back directly through here. Plus is a big number trend line, because as Igor showed in that data model, what we're really looking at is workspace activations and specific metrics around that. So I will grab that data set that we saw was already in my space, create a new chart based off of that. And again, all of this information, the schema information and everything, sorry, this is just where the Zoom like little header thing blocks your tabs out. So I'm just trying to find, so within Cube Cloud, the one thing that was important to note was that the schema is already defined. And so what the columns are doing are also pretty clear. So if I go back to let me just shrink that. If I go back to where I was just building this chart, if I wanted to, let's say, see how many active workspaces I'm creating month over month, I want to see the growth that we're experiencing. I can drop this right in as a metric. And one thing, I actually made this mistake. So when I was first doing this demo, so I'll actually show it to you because I thought it was a really good thing that Superset will prevent you from doing. So I'm going to hit count of n active workspaces. And what you're going to actually see should be an error, which is really cool because what you've actually done is you've protected yourself from making a mistake like that within this semantic layer. The n active workspaces has a SQL type and a metric associated with it. So as an end user, as an analytics like consumer, that kind of stuff, I don't have to go bother my pipeline builders anymore for. So we know what the mistake was. It wanted to count distinct. So what I can do is just change that metric, update the chart. And because all of this is already done, we should be able to see our big number trend generate. Let's see. It's taking a bit longer than usual, though.
Probably that's because we're calculating distinct counts, and that's our 20 mil row data set.
Oh, but there we go. So yeah, the data set actually, yeah, it became larger, but we have this chart ready. Superset will also do caching for you. So now what we can do is we can actually put in a comparison period lag, for example. And what I will do is I will also click the show timestamp so we can see this. Comparison suffix. I'm just looking for month over month. Let me update this chart. And we can actually see this is on a day range. So we can actually see our month over month growth in active workspaces. Now I can save this directly to the dashboard that Igor actually already created for us. I'm just trying to find the name of that. Workspace stats. Everything you just saw populating there were some of my own. Oh, so actually add the dashboard here to. I'm not sure why. Yeah, I'm not sure why it's not connecting to it here. But anyway, what we can do is actually just save this directly. Save this as activation rate over time. Just save the chart itself. Now, if I go to my charts, I can just add this into, I should be able to just add this into my dashboard now. So save. I'm not sure why this isn't showing up.
Yeah, there's a glitch.
That, of course, during the live demo, that kind of stuff happens. Let me just open up the dashboard instead. I promise that doesn't normally. It should have just saved, huh? Yeah, this looks like kind of a nasty bug, but I will go back to the dashboard itself through here, workspace stats. We can edit the dashboard and we can just add, this was the chart that we actually just created. So this is also a simple way to drop it if it shows up in here. Oh, it doesn't like the, we have to do a little bit of custom formatting there for this, I guess. Extend the page. But we can see it. I won't add it to the chart for the time being. One thing I did want to point out though, which was cool, was one of these things. So we already actually have an activation rate chart and we can actually see what the query is. If I go into edit chart here, one thing that a superset graphs also allow you to do is use custom SQL metrics. And here we can see the custom SQL was simply activation rate. But the reason that that works, when Igor was pointing out this data model, we can see that activation rate is a pre-aggregated metric. So it is treated as custom SQL, and we can actually see it right there. That's what it's performing. Coming in as a column, you don't have to worry about recalculating some of these things on your end. And again, this is why using tools that are, decoupled from each other, there's a real benefit and an advantage of. So I apologize for the bugs. I'm not exactly sure what happened to adding everything, maybe just too many tabs and everything open, but I'll stop sharing for now. I think we covered everything that we wanted to, and open this up for the last 5 minutes for Q&A. Any other last thoughts from anybody? Anything that we can answer for you?
Yeah, and I think that we have an amazing question, which is under the open tab right now, because it allows us to segue into a topic that we just briefly touched, right? So the question is, does Cube use the compute query power of the database itself, or does it store the data inside Cube? So the answer is yes to both questions. So, and let me unpack this. And I'll be unpacking this while sharing my screen again, because I just want to show some interesting things to you. So obviously Cube reads data from the data sources. It just gets the queries from Superset side, uses the data model to translate them into the SQL for the underlying storage, and runs those queries against the underlying storage. Postgres, in case of this demo, it can be BigQuery, it can be Redshift, can be anything. And if we go here to the queries tab, we'll see that we'll see the queries that were incoming, right? So the queries with these measures and no dimensions in this case, right? That were incoming, and Cube was running them against Postgres, right? Here's a SQL that was generated. You can see that, well, it took a lot of seconds, took a lot of time to run this query. But, well, this is actually not the kind of recommended setup for Cube, and not not a nice way for you to use Cube. So let me show something else. So very similar to Looker, I'll be entering the so-called development mode, which lets me basically create a private branch of the data schema and private version of the API, right? And here under their pre-aggregation section, I have a few declarations which are commented. Well, I'm uncommenting them, saving the file, and I'll be committing it and pushing. So I'm just saying add pre-aggs. So let's talk about pre-aggregations. Pre-aggregations, this is a Cube terminology for analytical rollups or just or just cache, right? And those pre-aggregations, they basically list the measures and time dimensions and dimensions that you frequently see in your queries. And then what Cube does, it prefetches the data on a given schedule, stores them internally in a very performant custom-built storage called Cube Store. It's written in Rust. It's very performant. It uses Apache Arrow formats for data transfer. It uses Arrow Data Fusion Query Engine internally. Very cool stuff. And then it transparently pre-caches the data for you, and so your query can run fast. So yeah, so we can see that pre-aggs were added, and if now we jump into this pre-aggregations tab, we'll see that, well, indeed, there are some pre-aggregations. We can navigate here, we can see the definition, and we can preview the data. So this is basically some condensed versions of the data that you have. So another pre-agg, we can preview that. Well, looks different, but this was pre-calculated. So if we go to our dashboard right now, and if we say refresh dashboard, we can see that, well, some of the charts refreshed pretty fast, right? Done, right? I can do this once again, done, right? And if we go to the queries tab right now, you'll see the status of the queries that we are now running. This nice bolt means that the query was accelerated with a pre-aggregation, and you didn't have to do anything other than just having them defined in your data schema. The rest is handled by Cube, and now your queries take just 100 something milliseconds to run, and not kind of 31 seconds, not 42 seconds. This is the power of the centralized caching layer within Cube. And this is actually the recommended setup for the caching layer. And with this, your dashboards will be appearing, in under a second, right? And that would be this is going to be the experience that you really should be getting from your dashboards. So hopefully that answers the questions about whether Cube reads it from data sources or stores the data internally. It does both for you. Okay, do you have any other questions?
Open 6. Let's see. After we complete the Cube definition, what triggers the Cube processing and how often is it refreshed?
Oh, cool question. So the pre-aggs that, well, that can be fully customized, and there are kind of two frequent ways to set up that. One is to set up a schedule, so you can just say, hey, refresh this every minute or every hour or every day. Another one is to provide a custom SQL that would be continuously checked, and when the result of that SQL changes, then Cube would trigger a refresh. And also, just as we speak, the team is working on Airflow integration, so you're able to trigger a pre-aggs update with Airflow. So hopefully that makes sense.
And there was one question from Costi about metrics from Cube showing up under the metrics section in Superset rather than columns. Yes, that is possible to do. What you need to do is you need to actually go and certify the data sets, and you can specifically call out columns as metrics.
Okay.
And then within Superset, it would show up in your metrics layer. In this case, this was a rough example. We just kind of pulled the data set. But normally when you're providing these sorts of dashboards for actual consumption and use, you would do all of this like cleaning up and sort of organizing ahead of time. But yes, it is possible.
I see a question related to their preset/superset release cadence. So how long does it take for preset to make new release of superset available in preset cloud?
We're typically bleeding edge. We fork almost on every release. So that is, you will always have the most recent stable version of Superset in preset cloud.
Cool. Another question for Superset: is the view underlying data feature available in visualization? Not sure what that means.
Could you expand on that? Is viewing the underlying, do you mean like viewing the query that's generated, or viewing like the structure of the data, the database? Because all of the schema information, everything from the database, those settings are always ported over into Superset.
Yeah, and I see a question about cube. So it reads, after we complete the cube definition, what trigger the cube processing, how often it is refreshed, and how? Well, that's a very deep question, right? But hopefully I can just quickly highlight a few things and let you explore the rest in the docs. So yeah, here's a schema, the data model that we were exploring and also tinkering with. And here on the overview tab, you can see a list of builds. So every time we merge the changes into their main branch, a build is triggered. That can also happen due to the data schema change. On the GitHub site, you can have your integration with GitHub. But the thing is, the data model is built and deployed here, right? And when it's deployed, we can see that the build number 6 is currently running. Cube is able to serve your queries. So they come into the SQL API, through the REST API, GraphQL API, doesn't we can do it instantly. So there is just a very short span, probably just tens of milliseconds between, okay, I'll put it like this. It takes seconds to deploy a build, and once it's deployed, and Cube is able to serve your queries. And in Cube Cloud, when one build is replacing another, well, you have this kind of continuity. There will be kind of no interruption in how your queries are served. And also there is a setting which is called, where it is actually. Oh, I think we've been moving things around. Oh, okay, probably. Oh, right. So I need to switch to the cluster mode, which I can do because I'm on a free tier here, right? So I'm using a completely free version of Cube and Cube Cloud. So yeah, but if I switch to a cluster mode, then I'll have this option to do the pre-aggregation warm-up. And basically, if you change your schema and you added a pre-aggregation, then after the deploy was done, and after the build is complete, Cube will also trigger the rebuild of all your pre-aggregations. And only after that, Cube will be serving your queries. So basically it means that at all times users will be getting the most up-to-date, the most fresh data from the Cube API.
And there seems to be one about pre-aggregation being kept frequent. Are you asking on Cube's end or Superset's end about checking whether the data changed? I mean,
yeah, I can.
Yeah, you can.
I can probably try to answer it from both sides, at least
yeah, exactly.
As far as my understanding of the caching feature of Superset goes. So as far as I understand, yeah, there's a built-in functionality in Superset, right? And when you refresh the dashboard, well, initially Superset will fetch the data from Cube, and then if you can doing frequent refreshes, it will instantly provide the data, and you can trigger a manual refresh. And obviously you can configure what's the kind of cache interval, right, and how frequent the data should be fetched on the Superset side. At the same time, on the Cube side, when Cube would be serving the queries coming from Superset, it would be respecting the kind of data, the data freshness, right? And that can be configured in the pre-acts, right? So here on the schema, we have a way to set up this. So this is an option called refresh key. And right now, my pre-acts are set up in a very simplistic way. So it just says, refresh the cache every day, no matter what. And you can set up, in very elaborate ways. And a completely different way to set up this would be to provide the SQL query that would be continuously checked by Cube in the background. It can be, for example, something like select max reporting day or select max updated that from the table, right? And once that query returns a different value, Cube will understand that the underlying data set has changed, and then it would trigger the rebuild of preax. So it basically means that your preax, your cache within Cube will be, just as fresh as your and the data in the underlying data source, and you can set up it this way. Or, well, alternatively, if you know that new data is added, say every day or every hour, you can just set up this way. Okay, say update this every day and be done with this. And there are good things about this setup as well. If you have a lot of data, if you're running Cube on top data source which is costly to run queries against, say you're using BigQuery and multi-billion data set, well, you might enjoy the fact that all queries which are incoming to Cube, they run against Cube's preax, they accelerate it with preaggregations, and they don't propagate to BigQuery. And the only queries which are run against BigQuery, that would be queries run by Cube on schedule, maybe just once a day, and that's you can fully control, and that means that you can also fully control the money you spend on BigQuery. Hopefully that makes sense.
And there was one question from Sean about a superset. So the way Superset treats everything is as a database connection. So any sort of metric, measure, dimension, what Superset can do is pick up like column annotations or column definitions for you, but they're essentially treated as like, this is a raw data set, this is the column, and this is what we're going to visualize. So if you want those like flags about this being a metric or that, there is no way around it. You would have to redefine in that sense in Superset, but the actual calculations or anything, nothing will change. All of that is being done in the Cube end. And each, like as Igor walked through that data model, each one of those fields was being treated as a specific column. And then that's why I wanted to show that custom SQL one as well, where the full metric was already calculated. And all we have to do is write the name of the SQL statement in as a metric. Hopefully that answered your.
Yeah, and what I can quite quickly add here is that, to the best of my understanding, in the scenarios where Cube is used with Superset, the current integration works just fine. Obviously we will be looking into ways kind of to tighten this integration, right? And as Shrisham said, we might be providing just additional annotations, right? That it can be read from the Superset side. But again, I've seen numerous setups when Superset was used with Cube, and the current way it integrates it's very sound. And truth be told, we are kind of well, obviously dogfooding Cube in Cube, and we have our internal analytics based on Superset, right? So that's what we're using, and truth be told, Superset was kind of the first BI tool integrated with Cube because we needed this for ourselves, and then we expanded expanding the range of available BI tools, and yeah, here you have the current SQL API.
I think the last two, those other two questions are for Cube.
Okay, so I think the question about KSQL DB might be answered with just a link to a recent blog post by Artyom, Cube's CEO. So yeah, yeah, right. Thanks for adding the link here. But the gist of it is that, well, as I said, Cube works with numerous data sources. It can be regular databases like Postgres. This can be cloud-based data warehouses like BigQuery or Redshift or Snowflake or Firebolt or ClickHouse. I can go on and on. But another type of data sources that Cube works with, these are streaming databases. And Cube supports Materialize, and actually, Materialize just got a very cool release yesterday. Feel free to check it. And also Cube works with KSQL DB, which is a streaming database in the Kafka world, right? So what you can do with Cube, you can You can stream your data to Kafka. You can set up KSQL DB, reading the streams from Kafka and defining the tables over it. And then you can connect KSQL DB to Cube. And well, the rest you've seen. You can define a data model. You can expose this data model through the APIs to BI tools or to other tools. And yeah, and I can probably show you this quick demo that we have. Yeah, okay, it loaded. So yeah, this is our architecture of this demo. So there's a web app we're currently looking at, and we can do some interactions that will trigger events sent to Twilio segment, and then these events will be pushed to Kafka, and then there's KSQL DB set up on top of that, and then Cube is reading from that. And if I press this button, we see changes, both here and here. And this is because the data propagated from the front end through segment, through Kafka, through KSQL DB to Cube and back. So yeah, hopefully that answers that question. And
yeah, and just to add to that, I posted this on one of the answers. Like, we have a workshop coming up next week as well, a little over almost exactly a week from now, to cover our streaming support workshop. So you can come join us there.
Yeah, what else? There is a question about, can Cube handle time-based aggregations, for example, last, which is necessary for inventory-like measures? Well, the obvious answer is yes. So time dimensions are parts of Cube schema, right? And obviously, when you trigger queries that have this where, and then there is this time column, right? And there is some date range or time range compared to the date. Well, this is what Cube SQL API can read. This is what Cube would translate into the query to underline storage, and yeah, return your data. And that obviously works with pre-aggregations. Probably a quick way to show this would be to go to the playground, run a new query, let it be just maybe count, right? So I wonder whether, it's not accelerate. What about number of workspaces? This one is accelerate. Okay, and yeah, and then we can do reporting day by week. And I guess this one should be accelerated as well. If I remember the pre-act definition, okay, it's not. I can see it's not, yeah, but the pre-act should be in effect here. So let me just quickly take a look at the pre-act definition. So, okay, activation rate by reporting day by week. Okay, so this one should work just fine. Okay, you can see that was quick. And this is the SQL that was run to enable this query. So you can see here that Cube is reading from something called proprietary aggregations workspace activation rate. And this is not our Postgres instance, right? This is a pre-aggregation storage, Cube store. But as you can see in the query that we were running, we have this measure and we have this time dimension, and we have the weekly granularity. So you can basically have the same on the Superset side, right? Superset will generate a query like this for you, and then Cube will be happy to run this against pre-aggregations. Okay.
And so we are like, I think almost 30-40 minutes over. This was an amazing amount of engagement, though. Happy to get so many questions. A recording of this will be sent to everybody. So, and also feel free to reach out to any of us you see here. But yeah, it was great presenting with the Cube team. Hope our audience got something out of this.
Yeah, thanks a lot. That was my pleasure, to do this with you, Srisham, and yeah, I'm always happy to see Superset used with Cube. As I said, this is kind of setup we are using internally Cube. This is a kind of setup that we see a lot used within our communities, right? And I would love this to expand even further. And thanks Thanks everyone who attended this call. I can still see, more than 30 participants on this call. Yeah, so
I'm amazed that they
amazing.
hung around this whole time. I didn't expect that. Usually people just drop right off.
Cool.
Yeah.
Okay, we should probably repeat this one, in a few weeks. Okay.
Yeah. We will send the recording out. So if you registered for this event, you'll automatically get that from Preset. Awesome. Well, everyone have a good
Thanks for having us.
Yeah, of course.
Thanks everyone.
Thanks, everyone.